These types of questions can be asked in two different ways. Either they'll give you a little sentence here with the description, or they'll give you the actual graph, like a drawing of the graph. And we will look at both types of questions. If they're giving you a drawing of the graph, they're not going to tell you what kind of graph. Does that make sense? If they've given you a picture of a parabola, you need to know that that is a parabola. Okay, or hyperbola, or an exponential graph. If they're just giving you the information in a sentence like this, they do have to tell you what kind of graph it is. Okay, you can't just say determine the equation of a graph, which has these points. They have to tell you which type. Okay. So you can just write down that question, please, and we'll do this one together. Now, guys, a parabola is probably the most, not necessarily the most difficult one, but the most complicated one because it has three forms. Right, to remember that a parabola has three forms. I'm going to write that on the side there. Or wherever you have space, you can do it underneath as well if you didn't write it like I did. So there are three forms of a parabola equation. I just want to make sure you're all done here. Yes. Fine, I can see that some people are all right. Okay, three forms. We have standard form, right, which is y equals ax squared plus bx plus c. And are you going to use standard form if they've given you the y-intercept? Do you remember what is the y-intercept if you're looking at standard form? C, right? So if they've given the y-intercept, you are going to use standard form. The y-intercept, and they'll have to give you some other points. Okay, but that is almost like a landmark for using standard form. The other form that we had was turning point form. And surprise, surprise, if they gave you the turning point, you're going to have to use this form. Okay? So, given and then the third form, which we don't really use all that often, but it can obviously come up, is x minus x1, x minus x2. What is this form called again? X-intercept form. So if they have given you the x-intercepts, then you're going to use this form. So unfortunately, guys, you're going to have to memorize this information. Okay. Hyperbola is just one form, so if it's a hyperbola, you use that form. Exponential graph is also just one form. If they give you an exponential, you use that form. For parabola, you're first going to have to look at the information that they gave you, decide what have they given me, and then use that form. Okay, now if we look at the information that they gave us, how many points did they give us? 3 points. Did they tell us which types of points these are? Did they say y-intercept, x-intercept, turning point? No. So we're going to have to look at these points and like decide what types of points these are. Guys, I just want to point something out here. I'm not intended. I just want to show you something here. Look at these first 2 points. Do we see that they both have a y value of 0? These are x-intercepts. Good. All right. These 2 points, even though they didn't tell us that they're x-intercepts, we need to know that we have y values equal to 0. So these are the x-intercepts. If you go back to all the graphs that we've drawn so far, guys, whenever we calculated an x-intercept, what did we do to get the x-intercept? We made y equal to 0. So any point with a y value of 0 is an x-intercept. Okay, they're not going to tell you that. They're not going to say with x-intercepts this and this. All right, if we're giving you the coordinates, you need to see my y values are 0. So that means that those are x's. And then they've given us a third point. We'll see now why we need that third point. But guys, they've given us the x-intercept, so we're going to use x-intercept 4. Okay, so let's write that down. We're going to write y equals a x minus x1 x minus x2. What always happens with an x bracket in the equation and in the coordinate? It always has a different sign. Same thing here, guys. These are two x brackets. Do we agree? So just like with the turning point, just like with true graphs when we were shifting, the x bracket always has a different sign in the equation and the coordinate. So this is positive 2, guys. That means I'm going to say x minus 2 in the equation. All right, the x brackets always have different signs. That a we're going to leave like it is for now. We don't know what that is. Okay, that's positive 2, but I'm going to say x minus 2 in my bracket. The next x-intercept is negative 4. So in your bracket, you're going to say x plus 4. I'm going to make a note just on the side here, guys. X brackets always have different signs from, let me not just say different signs, have different signs from coordinates. And this is our final answer. Can I read the equation like that? So that A is. So then we find what A is, right? Guys, that is why they gave us 3 points. So they gave you the 2 x-intercepts so that you can put them in the 2 brackets. The third point you're going to use in order to get your A value. Now the third point, you are just going to sub into the equation. Okay? So we're going to sub in the 0.48 into this equation. This was y, right? So what is y of this point? What's the y value of this point? 8. And we say 8 is equal to A. We don't know. We're trying to find that out, right? We're trying to calculate that. Now, in that bracket, I have x minus 2. What is the x value of this point? 4. So we're going to say 4 minus 2. And then in the next bracket, we have x plus 4. The x value of this point is 4. So I have to say 4 plus 4. Right? X plus 4 is now 4 plus 4. You guys see that now A is the only variable. Okay, so we start in that point. Get rid of the y and the x's so that A is my only variable. Okay, we can work this out, guys. What's 4 minus 2? 2, okay? And 4 plus 4 is 8. What's 2 times 8? 16. Okay, so we have 8 equals 16a. Right? If you don't want to do that in your head, you may be anxious, you don't want to make a mistake, just type it into the calculator, right? That bracket times that bracket is 16. So what must I do to get the value of A? What must I do with the 16? Divide, but remember I have an 8 on this side, so now I have to say divided by 16, okay? So A is going to be 8 over 16, which is actually a half. So what is my equation? y equals, we just got our a value, we're now just subbing it in there, right? A half, bracket x minus 2, bracket x plus 4. And leave it like that, guys. That's one of the three forms of the parabola equation. So you get 4 marks for leaving it like that. If they maybe say in the question, write your answer in standard form, what do you think you would have to do then? How do I go from something that looks like this to something that looks like this? We're going to have to multiply out. Okay, so just pay attention to the instructions there. If they say leave your answer in standard form, you're going to have to FOIL these brackets out and leave your half in front, FOIL them out, and then multiply the half. Okay. All right, second example. Determine the equation of a parabola with a turning point 1, 2, passing through the point 2, negative 1. Yeah. Let's see, you would get a mark for subbing in these two. Then you'll get a mark for subbing in the point, a mark for calculating A, and then a mark for okay, back to that question. Just copy that down, please. Okay, are we ready? All right, so again, we're telling us that this is a parabola, right? So we know we have those three forms. So in order to decide which form we're going to use, we need to look at the information that they gave us. So they have obviously given us the turning point. So we're going to have to use turning point form. Okay, so y is equal to, and guys, it is a good idea to actually just write the form down before you start putting values in. So that you know exactly what you're working with. Now we need to put the turning point into that equation. Okay, and remember that it's going to be P and Q, those are the coordinates. Guys, again, in an X bracket, it always has a different sign from in the actual coordinate. So the X coordinate is 1. That means that my X bracket is going to be X minus 1. Okay, so we have equals A bracket X minus 1, and then you square that. The y value always keeps the same sign. Okay, so it's positive 2, so that's going to be a plus 3. All right, again, and this is obviously equal to y. Again, I have everything now except for a, which is why they gave me another point. All right, so just like in the previous example, so that we can calculate a, we're going to sub in the other point, because that will get rid of the x and the y, and we can then just solve for it. All right, so we're going to sub in the point 2, negative 1, the other point that they gave you. Guys, they'll never give you information that you don't have to use. Okay, so if you're working along and you're like, oh, they've given that point, I haven't actually used it, then that's what you need to do. Okay, you have to use all the information that they've given you. All right, so this is the x value and that is the y value. So instead of y, we're now going to write negative 1. So that is the y value of the point. equals a bracket x minus 1 is now going to become the x value minus 1. So 2 minus 1 and then squared and then plus 2. Now this looks a bit more complicated than it actually is. You can put in a middle step of just calculating what this bracket is equal to. But you don't have to, but I'm just going to write that. What's 2 minus 1? 1. And then 1 squared is just 1. So a times 1 is just a. And then you have that plus 2 there on the other side. So what must I do to get a on an R? Move this plus 2, it's going to become minus 2. What's negative 1 minus 2? Negative 3. You can also say negative 3 equals a if you want that. Okay, and that's it, guys. Now we just need to write the equation, putting that a value in. So now it's going to be negative 3 instead of a. I'm looking up here, and then you have your x minus 1 squared bracket, and then plus 2. Okay, you can leave it like that again. Again, if they ask for it in standard form, you're going to have to multiply out. So you'll put this as x minus 1, FOIL out, and then add the 2 again. Okay. I'm going to do another parabola question now. I'm going to move on to the hyperbola ones. Okay, so number 3. Let's try and take this question now. A hyperbola, and then has 2 asymptotes. Okay, are we ready? Again, they're telling us that it's a hyperbola. Alright, so do we remember the standard form of hyperbola equation? Y equals a over x minus p and then plus q. Hyperbola only has one standard form, one form, so we don't even have to think twice. We know that it will be that. Okay, now the first thing that you're always going to do, guys, you're going to put in the asymptotes. Just like when we're drawing the graph, the first thing that we draw, or the first thing that we even write down, is always the asymptote. Okay, so that's going to be the first thing that we put into this equation. The x asymptote is going to go with the x. Remember, what do we do with that sign? We need to change it. So it's x equals positive 2 in the equation. It's going to be x minus 2. So we're going to say a. Again, we don't know what that a value is yet, so we can leave it for now. We're going to say x minus 2. Q is the y asymptote, and does that asymptote change its sign when you put it into the equation, the y one? No. Alright, so it's still going to be minus 1. Guys, just for doing that, we get 2 marks. A mark for that, and a mark for the minus 1. And this is why. If you don't know how to get A, at least you've already got 2 marks. Okay, for putting in the asymptote. What do we think? How are we going to find A? Sub in that 0.41. Okay, just like we've been doing with the other examples. So we're going to sub in the screen a bit here. Sub in 4, 1. So y is now the y value of this point, which is 1 equals a over x minus 2. What is the x value of this point? 4. So 4 minus 2, and then we minus 1 from it. A little bit more complicated to solve for a in this one than the others, but not that bad. We're going to move that minus 1 over to this side. What do I do with it? Plus 1. Hey, so 1 plus 1 is 2. And what is that equal to, guys? Can I simplify this? What's happening in the denominator? 4 minus 2 is also 2. And then you get a on its own times 2 times by 2. Hey, on this side I'm dividing by 2. On the other side you're going to times by 2. 2 times 2 is 4. So a is going to be equal to 4. Therefore, sorry, I'm just writing it here on the side because I'm running out of space here at the bottom. The equation is y equals 4 over x minus 2 minus 1. Right? If you know your work, if you know the actual theory, you know the form, you know what and what in the form, actually not have that. These types of things. Okay, any questions? We're going to do one quickly where the actual graph is drawn for you because obviously you can get questions like that. So for the 4, you can just draw your participant plane. Let me just quickly finish drawing this graph before you copy it down because you might just need to see about spacing. So that is the asymptote. Can we just quickly do this? Okay, that's the graph side. We can copy that down. I'm just writing EQN for equation, right? Never mind. Okay, guys, what kind of graph is this? Hyperbola. All right, good. So we're going to write the standard form of a hyperbola equation. Y equals, same as in the previous one, a over x minus p plus q. Did they give us the x asymptote? Yes, x equals 1. So I'm going to write x minus 1, right? Because this is positive 1 in the equation, it has to read x minus 1. And so we're going to say y is equal to a over x minus 1. What about the y asymptote? Is there a dotted line drawn in for the y one? No, but can we tell what it is actually by looking at it? It's the x-axis, hey? Sorry, I actually forgot to put my thing. Right, the x-axis, do we see the x-axis is the asymptote, the y-asymptote in this case? We can see that by looking at the graph. You see it's going closer to the x-axis, but it's not touching it, and the same thing there. Right? Now, can anyone remember what this is? The x-axis, what's the equation of that line? Good, y equals 0. Right, so this q value is actually 0, guys. So do you have to write it in if it's 0? No. Okay, I'm just going to add a little note here. Just like pointing towards this blank space here. X-axis is asymptote. And then in brackets, I'm just going to write that is y equals 0. So if you want to, guys, you can write plus 0 there, but you have to put it in the final answer. And it's not, don't write 0 in the final. Okay, how can I find A? What do you think? Something that other point that they gave us, right? Which was 0, negative 2. Oh, you see that doing the same thing every time. Okay, so now we're going to sub in. I'm just going to do it more to the side. Sub in 0, negative 2. So y is now the y value of this point, which is negative 2, and that is equal to a over x minus 1 now becomes 0 minus 1 because my x value is 0. You can simplify that. You don't really have to write this as a separate step, but I'm just going to do it for the sake of completeness, right? 0 minus 1 is negative 1. So to get a on its own, on this side I'm dividing by negative 1, so on the other side I'm going to have 2 times by negative 1. Times negative 1 is positive 2. Good. So a is just 2 in this form. So therefore our equation is going to be y equals 2 over x minus 1. Good. Okay, I'm not going to get to exponential graphs today. Because the examples that are in the book, which are the ones for the example, this is the one that I'm going to do, is a bit more complicated. I'm not going to do that 15 minutes to work. Okay, so are there any questions on parabola hyperbola? Basically the same thing that we're doing every time. Okay. So I'm going to give you, now the questions are from 2 different exercises, guys, because they split it up into parabola and hyperbola. So you are going to do exercise 5 on page 19. Okay, guys, exercise 5 is about parabola, and 8 about hyperbola. I just want to point out that in exercise 8, they're also saying find the equation of hyperbola and state the equations of its symmetry lines. Now, we haven't spoken about that in a while, but symmetry lines are the same as axes of symmetry. And so we have done that for parabolas before, so you're going to have to probably just look at that note that we wrote. See that you are able to do that. Okay, get going. You have 8 minutes, guys. You can do at least the first 2. I just want all fit here on my page. Okay, I'm gonna put 1.1 and 1.4 up. Have you copied that now? Have that written down, please. But then question 2 is on the next page, unfortunately, so I can't put. Okay, there we go. 1.1, 1.4. Can you read that? No, you'll have to go to one of the wall.